Now I'm going to teach you how to compute the similarity between two examples. And the way we'll do that is we'll look at how to compute the distance between 2 points. When we're doing the nearest neighbor classifier, the classification rule works like this. We have a new patient before us. We want to know how to classify them. So we look for the most similar patient in the training set. In other words, out of all the historical data we've got, we look for the most similar historical patient. And then we use the known diagnosis of that past patient to predict the diagnosis of the patient in front of us. So we've got to have a way to compute similarity between patients. And the way we'll do that is by using the distance between 2 points. If we think of each patient as representing a point on some scatter plot, if we have 2 patients, the closer they are to each other in the scatter plot, the more similar they'll be. So to figure out how similar patients are, we're going to need to know how to compute the distance between them in the scatter plot. And that's what we'll work through in this video. Our data set is organized in a table. So each row of the table contains all the attributes for a single patient. Let me just give you a refresher of some of the Python operations for gathering the data about a particular patient. If we want to focus on the ith row of the table, the ith patient, we can extract out just that row by using the .row operation. And that will give us all the attributes, all the data about that patient. If we now want to focus on just one of the attributes, then we look in just a single column. If it's the jth column, then we can obtain the number in the jth column by using the .item operation. So t.row parentheses I .item parentheses j means look in the table, find row I, column j, and give me the number there. Or if you want to interpret it in terms of this task, it says find me the ith patient and tell me the value of the jth attribute of that patient. In this example, all the values, all the attributes we're dealing with are going to be numbers. And it's sometimes handy to put things in NumPy arrays. So if you have a row that are all numbers, you can convert that to an array by using the NumPy's operation mp.array. And that'll put it all as an array. And then we can use the array operations we've learned in this class to manipulate all those numbers all at once. Also useful in the code that's to come, if we want to do something for each patient, we want to do some operation for each row in the table, then you can do that with a for loop. Here we have a for loop. If the for loop says for row in t.rows, do something, what that for loop will do is it's going to iterate over each row of the table, and it'll run the stuff in the body of the for loop once for each row of the table. So t.rows says, give me all the rows of the table. And for row in t.rows says, do something for each row in there. So each time assign the variable, the name row, to refer to the current patient we're looking at. And then run some code. And then go to the next row and update the name row to refer to that next row and do something, and so on. Okay, so that's just a little bit of a Python refresher. Also, let me give you a little bit of a math refresher about how to compute the distance between 2 points. If you have 2 points, and you want to know the distance between them, then we can compute that as the square root of the sum of two squares. X0 minus x1 squared plus y0 minus y1 squared, the square root of that. Maybe you remember this as some formula. And if you don't, there's an easy way to explain what's going on. This is basically the Pythagorean theorem. So let me show you with a picture. I think that'll be the easiest way to understand this. Let's say we've got 2 points on this scatter plot, and we want to know the distance between them. So I've got a plot here in the middle, and I've got a point in the upper right, and I want to know the distance between, calculate the distance between these points. Well, the distance is the length of this line that I'm drawing. So I want to know how to compute the length of that red line that I just drew. Well, a way to do that is to draw a little triangle. Let's draw the base of the triangle. There's a horizontal line. Let's draw the height of the triangle. There's a vertical line. And you'll notice that's a right triangle. So if you remember your high school algebra, then Pythagorean theorem says a squared plus b squared equals c squared. In other words, if you square the length of the horizontal line and you square the length of the vertical line and you add them up, and then you take the square root of that, that'll give you the length of this diagonal. And the length of the diagonal is exactly what we wanted to compute. That was what the distance we wanted to compute. So to get the distance, what you need to do is find the length of this horizontal line. You can do that by looking at the difference between the x attributes of these 2 points. Then you want to find the length of the vertical line. You can get that by looking at the difference between the y attributes. You square those, you add them up, and then take the square root. And that gives us the formula that we have shown here. All right, that works if you have only 2 attributes. What if you have more than 2 attributes? Like in this breast cancer diagnosis data set, we had, I don't know, 8 or 9 attributes. What do you do then? Well, if you have 3 attributes, you just generalize. If you have 4 attributes, you could probably see what the pattern to do is here. So we look at each attribute, we take the difference in values of that attribute, we square it. And then we look at the next attribute, we take the difference between them, and we square it. And we look at the third attribute, we take the difference between them and that attribute, and we square it. We sum up all those squares, and then we take the square root of the result. Okay, so that's a way to get the distance between 2 points, or in our case, the distance between 2 patients. All right, so let's work through that in code. I want to write some code to compute for me these distances. So let's look at how we would write that in Python code. We have these 2 points. Let's assume that they're represented as arrays. I said the way you get the distance is you look at the difference between them in each attribute, and you square them. Okay. Well, what I could do is I could do something like this to get the difference between them in their first attribute, and then square that, and then get the difference between them in their second attribute, and square that, and so on. But that gets a little tedious. So actually, I'm going to do a clever version of that. I'm going to use array arithmetic to do this all in one go. So if I take the difference between these two as arrays, I get a new array that has the differences. Then if I square that, I get an array of the squared differences. So there's a whole bunch of squares in there. And now what the formula tells me to do is to sum those up, to add up those things. And then finally, the formula tells me, please take the square root of that result. And that will be the length of the diagonal line, in other words, the distance between the points. Okay, so that's how I can compute the distance between 2 points in Python if I have them as arrays. What if I've got them as a row in a table, if I've got 2 rows in the table and I want to compute their distance? That's another situation that'll come up. So let me write a little helper function to do that for me. And I'll give it a different name. Since now I'm working with rows, I'll call it row distance. Okay. So if I have 2 rows, this will compute the distance between those rows. You can probably guess how I'm going to do it. I already know how to compute the distance between 2 arrays, so I'm going to convert these rows to arrays and then use the thing I already know how to do. Okay? So let's convert the first row to an array. Let's convert the second row to an array. And now that they're arrays, we know how to compute the distance between them. We use that function we just wrote. I call it distance. And that'll give me the distance between them. Okay. So in this way, I obtain some code that will let me compute the distance between 2 patients, 2 rows in the table. And this distance is my notion of similarity. A small distance represents similar patients. So let's take the data set we got and focus just on the attributes. And let's walk through an example to show you how this distance thing works. Well, there we've got some patients, just their attributes. And I can compute the distance between 2 patients in this data set. Like, for instance, let's take the first row, row number 0, and the second row, row number 1. And compute the distance between them. Okay. And it tells me the distance is 11.87. I don't know how to interpret that, but what that's telling me is if I take this patient here and then this patient here, the distance between those 2 patients is 11.87. Okay? All right. Good so far, I hope. Now let's do the same thing again. But this time, let's compare patient 0 with patient 2 instead of patient 0 with patient 1 and see what happens. Now the distance is only 2.23. So would you say that patient 0 is more similar to patient 1 or more similar to patient 2? I hope you said patient 2, because the distance to patient 2 is much lower than the distance to patient 1. The distance to patient 2 is only 2.2, which is much smaller than 11.8. Okay? So what that's telling us is patient 1 is more similar, patient 0 is more similar to patient 2 than to patient 1. And if we actually look at the numbers here, that kind of makes sense. Patient 0 looks like they have a lot of small numbers. Patient 2 has a lot of small numbers in the same place. So patient 0 and patient 2, they're looking pretty similar. Not identical in their numbers, but they're pretty similar. Whereas if you look at patient 0 and patient 1, they look pretty different. Like, whoa, look here, bare nuclei, 1 versus 10. That's a huge difference. There's some places where they're similar, 3 versus 3. But there are also some places where there's a big difference, 1 versus 5, 2 versus 7. Okay, so this is telling me that patient 0 and patient 2 are a little more alike, and maybe we should expect them to be more likely to have a similar diagnosis, whereas patient 0 and patient 1, who knows, maybe they do or they don't have the same diagnosis. Lastly, one more example. What happens if we compare patient 0 to themselves? What kind of a distance do we get? The answer is distance 0. That kind of makes sense. That's the smallest possible distance. You're very similar to yourself. Okay, so in summary, this is how you can compute distances, and distances are going to be useful for the nearest neighbor classifier because the lower the distance, the more similar the patients are. And we're going to use that because the more similar two patients are, our intuition says, seems likely that they'll have a similar diagnosis.